Hi, welcome to the See Beyond show. And today I have Goran Roos out of UK with me here. Welcome to the show, Goran.
Thank you, Mikael.
Yeah. So a brief background on yourself. You've been doing so much, but you're a visiting professor to the Cranfield University in UK, with Flinders University in Australia. But what I find really interesting with you, I mean, you're actually an advisor to corporates, to governmental bodies, and very much looking at, let's say, the strategies and into the future, as I see it, from my point of view with you. And that brings me to the topic of today. I actually want to learn more about strategy. What kind of strategies to implement now when we have been in this pandemic period and going, or let's say, post-pandemic? How do you see this?
Well, this is not the first pandemic that mankind goes through. So we have had the odd one before, some pretty bad, some lighter one in the 60s, for example, with the Hong Kong flu. And what they all have in common is that the world that when you come out of the pandemic is somewhat different from the world when you went into it. So going back to normal does not mean that we as a society will go back to the way it was before the pandemic. There will be differences. Yeah. And these differences will be driven by behavioral changes in people. I mean, we have learned different things over this pandemic. As an example, the people who have never used shopping online before have now learned that it is an extremely convenient way of shopping. And they are not going to go back to physical shopping once it is possible to do so to the extent that it was before. And that, of course, will drive changes in the logistics systems. You can see that truck manufacturers have had incredible demands, well over expectations of the last pandemic. Good results for companies like Volvo and Scania and so on, because of the logistic demands that follow some online shopping. And retailers have had to restructure themselves. Manufacturers have had to restructure themselves. So the new world will be different, not maybe as different as some people say, but it will be different.
Yeah. I mean, you actually took my words there, or questions actually, because already I was thinking that the same way, because of course what we see is many say, oh, when are we getting back to normal? But of course it's changed. And what we've all learned, I mean, now we're sitting over this virtual platform communicating and having this discussion, and that's happening everywhere in business, in daily life. So of course we have a lot of these digital services, and that will just continue like that. But of course also we're locked down. We have travel restrictions, and even though we can perform a lot with the digital services, and actually having to rely on domestic supplies. I mean, how is this actually shaping the future now with manufacturing and having this type of supplies?
Yeah, it's so let me try to divide that into two bits. So what are these sectorial impacts moving forward? And in essence, you can say that there are four different sectors. There are those that have experienced an increase during the crisis, increase in demand, and then it will be followed by a decline, of course, afterwards, but it will still end up on a higher level after the crisis than they had before. These are online shopping, delivery of meals, something about health and education, entertainment services, the big streaming companies and so on. Then you have those that have a demand drawn forward. There was a demand, but it's been drawn forward. And that means that it will then drop down, but settle once it's kind of captured up, settle on more or less a similar level. These are things like, DIY material and tools. People have done a lot of home renovations and so on, installation of these type of household appliances and office furnitures for home, and you name it. So it's a lot of those activities where the demand was there, but it's become a bunch pulled forward and happened. So they will have a curve and bump and come back down. Then you have sectors that have a temporary declining demand because there has been a postponement of the procurement rather than drawing forward. So they've been pushed forward. So once they've gone down, and they will come up again. You have some fast-moving consumer goods, branded ones in that. You have automotive demand and so on that follows there. And finally, you are those that have experienced a large decline, and they will come up, but on a lower level. And there you have things like some tourism activities, business travel, business hotel services, a number of activities like that that will settle on a lower level than before. So that I think is the answer to your first question, that there will be different impact on different sectors.
Sure.
The second question is the question of manufacturing here. And what we have seen is a realization that the focus we've had before the pandemic, an incredible focus on efficiency, has been at the expense of resilience in supply chains. Mm-hmm. So it turns out that we have been in some supply chains very, very sensitive to disturbances. We have seen that occasionally before when there have been fire in maybe supplier of certain key components, or there have been earthquakes in Japan or whatever. So we've seen some of this, but it hasn't really driven the changes we have now seen, where there have been a rebalancing of focus in supply chain from basically only efficiency with some modifications to a more balanced view of efficiency and resilience. And that means that you are looking into your supply chain and a number of things. Firstly, you have to understand your supply chain to a much higher detail than you did before. So instead of just knowing maybe 1 or 2 level down, you really have to know it all the way down. And a lot of companies are doing those reviews. Then you have to look at this and see where are the risks. If this one drops out, what do I do? What are the challenges? And that leads to partly a move of certain critical component to suppliers closer to you. May not necessarily be in the home country per se, but it's closer to you, so you have a better control of what goes on. And the second is that you double up suppliers in some key areas. Now, so that is one side, and that's driven by resilience. Then we have the sovereign impact. In other words, there has been a realization that the service economy cannot provide vaccine or personal protective equipment or any other critical components. There is no such thing as a physical thing in the service economy. So there has been a realization that having a national capability to manufacture critical products actually is rather important. And therefore we see a number of countries that have started to try to refocus manufacturing and bringing it back and building up capability. And you can see 2 phases of this one. The first was the initial, we need this product to sort it out. So many countries basically said to their, the kind of research organizations, the Fraunhofers of this world, and the companies say, what can you do to instantaneously produce product X because we can't source it? So that's the first issue. There was also a reaction because a number of countries broke international trade rules. So even though you had key components ready to go from a country, I think France was involved in this among other things, it wasn't allowed to leave the country to where it was going in its manufacturing supply chain system because they retained it. And that meant that not having those capabilities domestically was not good. So there has been partly a realization short term we need this, and then long term strategically a realization that this will happen again. We will have more pandemics and probably more frequently, primarily because of the density of population, how we live and all this kind of stuff. And that means that building up these sovereign manufacturing capabilities are critical. So from a principal point of view, it is a good thing to be in manufacturing. And the demand for manufacturing is going to be very good because we produce and consume more physical things than we ever done before.
Yeah, it's quite much to digest here. Yeah, definitely. With all the changes going on, and you have to be agile, and yes. That's kind of what I hear here, Göran. And of course, you were mentioning a few things I think are really interesting here to automotive area. What we see with the electrification. Now we see a lot of, let's say, gigafactories, battery plants, being built in Europe as well as in US. I mean, have we been sleeping, or are we late to the game here, or?
Well, I think what you see is as a rising awareness that we need to address the climate change issues. I mean, it has been spoken about for quite a long time. Many companies have done things, but there has been an acceleration and there will be a further acceleration of going green. I'll come back to the implications of that in a second, but there will be further acceleration because the restart of the economy, which will be dependent to some extent on public funding and already is, a lot of that public funding will be directed towards the kind of going green principle. So there is a need to do it, there is an awareness coming, there is a consumer behavior change, and there is governmental or public funds being available to restart the economy in that direction. So we can see all these things happening. Now that's generally a good thing. I mean, we are hitting about 400 ppm and we are closing in on 450 ppm of greenhouse gases in the environment, where we should never in the historic issue of this planet have we been around more than 300. So we do need to do something about this. That's absolutely clear and it's urgent. So that's clear. But it's not necessarily as easy as it's sometimes made up to be. If I may, I'll just touch on a few things.
Yeah, sure.
So basically, going green means going electric.
Yeah.
Right. That means that you need to change a number of processes. So you're going to go zero carbon steel, for example, and we have the hybrid project that takes place, for example, in Sweden with SSAB and LKAB and Vattenfall and so on. And this means that you need to then replace coking coal with hydrogen. Now, that hydrogen needs to be produced, and in order to produce it, you need clean water and you need electricity. So this transition is about, for the steel part of it, just the steel making is about 15 terawatt hours, which is around a large nuclear reactor equivalent. Then you have the change that is necessary in the pelletization process, both the process and the end pellet to make it suitable in this new area. That will require about 50 to 55 terawatt hours. So that's another 3 nuclear power stations, give or take. Or if you wanted it, about 4,500 square kilometers of windmills of a 7 megawatt capacity, which has 154 meter diameter wings. And that is about $60 billion at today's prices to build those windmills. They last 10 to 15 years. A nuclear reactor lasts 45 years and about $45 billion. So, that you have to be careful here. You need an enormous amount of electricity. And put in perspective, that transition of that green steel issue for those companies involved is about 45% of Sweden's total energy consumption. So there will be an enormous need for electricity moving forward. Now, and people underestimate, I think, generally what that means, and it requires infrastructure investment. It requires an enormous amount of generation capacity. Of course, we want that to be green, but what people tend to forget is that big windmills require concrete. Concrete is an irreversible process, so it's not a green product. And the cement industry is one of the worst industries from a carbon dioxide issue in the world. So there is a whole host of systemic problems that arise with this. Then you need to move the electricity from where you generate it to where you're going to use it. And that has all kinds of transformation issues that you need around dealing with this. And a lot of these requires electric engines. For example, the generator engines in the windmills or the electric engines in the cars. In today's world, I know there are technical issues dealing with other type of engines and so on, but in today's world, that means we're moving from a dependency of petroleum to dependency of metals. Right? So instead of having an OPEC that controls the oil production, with the exception of Norway, but you're now moving to a metal dependency, which is controlled again by a few countries, with China being the primary ones. So, and we also, in some of these scarce metals, we do not have enough of it to do it. I mean, if you just do your numbers, in order to make a permanent magnet, you need basically two rare earth metals, dysprosium and neopremium. Our annual production of dysprosium is around 1,800 tons, give or take. Making an electric engine for a car with using traditional magnets to withstand the high temperature, permanent magnets, uses about 100 grams of dysprosium, give or take, per car. So if you do math there, you can see with some efficiency around this, we can make about 1.8 million cars. There is about 83 million cars sold every year in the world. So, and we do not today have good technology on scale to recycle these things because the atoms are kind of spread out in the magnet, and it's really difficult to get them out. So there are certain limitations in this. And even if we recycle, we're not going to be 100% efficient of recycling. So actually the circular economy does not exist, because every cycle you do, you wear down and wear out the material, and you need to top it up with new material. And you must not only look at the material flow, you also have to look at the energy flow. And there's a lot of energy needed. And the more lasting the material, the more energy you need to recycle it. So you need more energy to recycle stainless steel than you need to do rusting steel. But because, and stainless is more lasting, but it requires more energy to recycle. So there is a number of flaws in the thinking around these things. It doesn't mean we can't do it, doesn't mean we shouldn't do it, rather the reverse. But one has to realize there are a number of complexities around this. But it's a great opportunity for science, technology, and manufacturing.
Yeah, that's great. I mean, it's complex, but summarizing a bit then, and I mean, we're kind of in this energy dilemma.
Yeah.
With this and how to solve it. We need to apply critical thinking, be let's say diverse in thinking about this and solving these problems. We must not give up.
No.
But like you say, look at the whole value chain down to raw materials, because that brings me another aspect here. I mean, metals and minerals. I mean, what we see now with the semiconductor side. I mean, automotive again, like saying that, oh, they have a shortage, they have to, let's say, wind down production, etc. Do you see changes in the semiconductor industry also?
Yes, you see, and the semiconductors are designated as a critical component from a national and security perspective. And as a consequence of basically being just a handful, depending, I mean, semiconductor is a wide field, so it depends specifically what subset you talk about. But if you keep it generally, the dominating producers sit in Taiwan and followed by Korea. It's very clear that and it's an extreme industry. There is no other industry which is so dependent on advanced science and technology, so capital intensive, and so rapidly moving. You know, you're betting your company every time you invest in a new generation or a new plant. And it's clear that over some time, the US has slipped behind in the technology side of the most advanced semiconductors. That will be rectified. It's an unacceptable situation, both in terms of level of sophistication and volume. So there will be new investments made in the US. Some of the Taiwanese companies will make new investments, Arizona, I think it is, and several plants. The US will spend a lot of money from a government point of view on building up capability in Intel and these other companies to bring them back up and the production facility. So we do see that this will be addressed. Now, there will be some clear winners out of this, of course. It will be the people who produce the machines that are used to produce the semiconductors, and they sit in Holland. So it's a Dutch company that will be the primary winner of a number of these increasing in manufacturing activities. We can't forget. I mean, Europe on the whole has a global leadership in the broadest definition of the term, machine tools. And these can be counted as machine tools, but for semiconductors, the same as we have machine tools in other areas. So we are very good at that. We may not be really good in many of the industries that uses these machine tools, but that is frequently forgotten when you look at Europe, that they have a number of traditional strengths which the rest of the world does not have, which is one of the strengths, for example, behind the German and Swiss economies, is the production of different types of machine tools in the broadest definition of the term.
Yeah. Wow. So that's interesting. I mean, if you talk a little bit about the winners, or not specific companies, but winning strategies here. I mean, what do you see for let's say, for instance, Europe then? What's a winning strategy now?
Well, if there was a simple answer to that.
Yeah. Oh.
It's I mean, what do you need? You need to build capabilities in these new emerging technology and associated industries.
Yeah.
So for example, if you're an automotive dependent economy, you need to really build capability in the ability to produce electric and maybe hydrogen vehicles, depending on your timeline issues. Sure. And that of course has huge implications, because there are an enormous amount of moving parts and components in an internal combustion engine car. There's only about 70 or 80 components in an electric car. So that means that the supply chains will be thinned out dramatically. So a number of companies will not be able to have a customer who presently sit in this supply chain. And that in its own right will be a challenge. So if you look at a country that is heavily dependent on traditional automotive, it has two challenges. The first challenge is I cannot stay in a dying business. I need to move to a new business. And that means building new capabilities, building new, understanding what the demand look, catching up with the early movers, a number of those challenges there, which costs a lot of money. And you will have scarcity of talent and capabilities. On the same side, you then have, from a government perspective, this is a company perspective, and they will do that reasonably well, I think, and they will develop their own supply chains and new things. From a government perspective, look at this, you're saying, I'm going to lose, there's going to be hundreds, if not thousands of companies that may no longer be viable businesses. How do I deal with them as a government? How do I deal with the unemployment they come out? How do I transition them? What is my plan for working with these companies that may devastate a small town somewhere, or may create a large unemployment, or whatever it may be? So these are challenges that follow from transitions in this area. And the transition is primarily around rapidness of moving from one area to another, which grounds in capability development. So people need to develop capabilities. I mean, there is, give or take, 1 million unfulfilled jobs in the EU or Europe generally that requires IT capabilities. And they are unfulfilled because we don't have enough people with those capabilities. Yeah. So there you go. So it's an interesting challenge. And also, you need then to source the raw materials. I mean, and that is not helped by the scarcity of some of these things and the concentration of something, and the increasing geopolitical friction, for example, between US and Australia on one side and China on the other, where China is totally dominating on a number of these raw material. And you can see the issue because US is now basically paying for exploration activities in Australia, which is a large place, mostly empty, with lots of potential minerals, in order to try to locate sources of these critical raw materials to reduce the dependency on China.
Yeah, I mean, that's one example. And like, I think I read a few days back in Germany, they find in the Rhine, under the Rhine River, the lithium sources, but nations growing desperate a bit, or trying to find the secure sources for it. But this is interesting, like the 1 million unfilled jobs in EU, for instance. But
approximately.
Yeah, approximately. But if you look at that, I mean, going a bit further there, I mean, future of work, or there's a lot of automation coming, robotics.
Yeah.
I mean, what's the future of work when we go 10 years forward in time? Yeah.
Well, there will always be a requirement for human work, at least through the lifespan of most people that are born today. So the question is not that. So if you look at it, it has to do with what is the routine component of your job? How much is repetitive routine? Because that can be automated. And probably it's a good thing that it's automated, because you don't want to do the repetitive things, The old Charlie Chaplin film comes to mind. It's that you don't want those jobs, and it's a good thing that they get automated. What you want is more sophisticated job that thinks about what the robot should do, right? So coming up with the new products. Yes, we will get more. We have more sophisticated system. We have machine learning tools that are helping us to identify molecules that has potential in flavoring or medicine or something, because it has the ability to very rapidly handle very large amounts of data, which the human can't do. But there are still a set of decisions to be made, around, what are the search parameters, where is the raw material selection process, what are the consequences for broader areas if you go this, that, and the other. So there are still going to be huge amounts of things, and that not to mention all the new jobs that are coming up. Podcast operator,
yeah. Or whatever,
blogger, influencer. These people did not exist 15 years ago, and they are completely new jobs. So I'm not too worried about this. There will be transition problems. And the transition problem primarily going to deal with capability development in individuals. And it is both the individual's responsibility and the institutions, be it government or companies, their responsibility to ensure that capability development is facilitated. Mm-hmm. So how would I like to see this happen? I would like each company or each organization, doesn't matter whether it's a government department or a company out there, I would like them to carry a descriptor of each of their employees around capabilities required for doing this job perfect or the next job, and then mapping where they sit on those things and keeping that up to date. And there will always be differences what you have and what you should have. And then they should pay a small amount matched by government, so when they no longer need this person, they can say to him or her, you're out of here on Monday, right? Which is but immediately when you're out, you go into a training situation where your documentation forms the basis for your capability development. And that is then matched by government pays for that in terms of an unemployment issue and the suitable. And you fall in your salary to say 70% of your salary. And then the moment you get offered a job, because you're now available, you get offered a job that can use the capability that you now have on a higher level, you take it. And if you don't take it, there will be a reduction in your 70%.
Yeah.
Because there has to be an incentive, right? So say 70% or 70%. So something like that. But it is so you get two things. You get a more dynamic labor market. You get automatic capability development, which is critical, so people are ready for new jobs. And you get an incentive for people to take these new jobs when they come up. You need to balance these. And the speed is critical, because in today's world, it is critical with speed. And we can see that. We can see the difference, for example, between the UK and Sweden in terms of paying out support in COVID. In the UK, it was out instantaneously. You applied and you got your money. In Sweden, you applied and 6 months later, if you were lucky, you got some money. And this is a real problem for small companies. It's not understanding the speed issues, the development. And that's the same with capability. The capability that you as a person working in whatever sector you do, and don't think blue collar here, think primarily white collar, workers in the old language. You need to constantly be up to date, because the speed of change means that the capability you had that was relevant 2 years ago is no longer sufficient. You need to be on top of this area. And then there will be new job. There will be huge amounts of job in building the infrastructure we need for tomorrow. There's no argument about that. There will be a new job we don't know exists. And there will be an incredible demand for job in sectors we can predict already.
I think this sounds optimistic and good also for the younger generation.
Yes, absolutely.
Yeah. So no one should give up, but we have to mutate. We have to be agile.
Yes.
Be ready to, let's say, it's not just one career or one type of role or education you will have, but over time you will have to shift and adapt.
Yes, and this is something that, and it has to be done. This is a joint interest between employers and labor representatives, call them unions, whatever you want. I mean, I have the greatest respect for a number of union representatives I come across primarily in Scandinavia and maybe some other places. But I still remember an interview that was done by an American journalist a number of years ago with a representative of the union for the Swedish mining workers. And there was in some technology shift. And I can't remember the question exactly, but it was something along the line of, are you not afraid of jobs disappearing now when the new technology come in? And the answer was brilliant. It says, as a union, we are not afraid of new technology. We are very afraid of old technology, because companies with old technology go under and then there are no jobs.
Yeah.
So it's a joint interest, and it's the same if you listen to the discussion in Norway between the Norwegian employers, NHO, and their unions around the presentation of the going green for the process industry. It was very much the same. There is a joint interest in having successful companies. Absolutely, it's in both parties' interest. Then you can fight it out how you're going to split the surplus. That's a completely different issue, right? But without the surplus, there's nothing to split.
Yeah. No, but I think that's to the point. And because to innovate, you have to collaborate.
Yes.
You can't be alone trying to do that impact. And shifting larger systems and structures, of course, you need to kind of find that core and the various players with it. Fantastic. Maybe even I have to listen to this many times, my own show, because there's so much profound knowledge here, Göran. But I would like to round it off and ask you about yourself. What's, if you are willing to, and able to share with us, what's your next quest or projects? What's around the corner? What can we expect from your side?
Well, you know, what I'm looking at is primarily what are the technology shifts that has the opportunity to impact sectors that traditionally have struggled with doing change, specifically in the green environment. One of the sectors we tend to talk relatively little about, or with relatively little information, is the greater agri and aquacultural sectors.
Yeah.
So food production, and I mean the whole thing from the field onto the plate, including transportation, everything like that, is round about 27% of our greenhouse gas emission, right?
Yeah.
And we tend to talk relatively little about that. We talk a lot about the industrial side. We talk a lot about the transportation side. And there are numerous things that need to be dealt with here. We need some sophisticated technologies. And here there is a conflict, primarily in the EU, between scientific advancement and political boundary conditions.
Mm-hmm.
The European Union is, and I'm going to be brutal here, is technophobic, right?
Yeah.
It has prohibited the use of biological technology in the genetic field, which has dramatically limits our ability to address green areas in this domain. It has a phobia around nuclear in many areas.
Yes.
And you can go through technology and nanotechnology issues. And yes, you should be careful around technology. I'm not saying you shouldn't, but you have to realize that there are certain technologies that are enormous in their potential. And if you limit those, you primarily exit from the opportunity to take wealth out of those technologies. You will be solely a buyer of the result of it, and that will impoverish you as a region. So look at things, for example, we know that mixing up certain algae in feed for cows reduces the methane emission when the cow regurgitates its food, being a ruminant, by close to 80%. Mm-hmm. And genetically modifying these macroalgae and the understanding of the bacterial interaction, which we can with very sophisticated technology, would allow us to reduce the methane emission from ruminants dramatically. And then that removes the argument that cows are bad for the environment, because you forget that if you take away milk cows, for example, from fields, then you lose biodiversity because the fields are nowhere kept open. And the biodiversity also has a risk factor. So there are all kinds of interesting systemic issues. So I'm quite interested in that area. And then, of course, I'm interested in a number of these new and emerging technologies that will have implication in the manufacturing issue. For example, there are 3 or 4 technologies for recycling these permanent magnets. and I'm tracking which of them are likely to have opportunities. And it is not certain that the one that on the lab bench has the largest potential actually has the largest scalable potential. So there are a number of issues understanding the TRL, MRL scales as you move up in this area, and which of them can do, or what countries should invest where in order to benefit from these things at the same time as the product is good for mankind.
Fantastic. And like, I'm also interested in the agriculture and food processing side. I mean, been thinking a bit more about that. And for those who are not acquainted with TRLs and MRLs, I actually had a previous episode with it was John Sates, who's been working in NASA with all of that stuff actually. So it's a possibility to check up that a bit. But I hope this could actually be something we can also do a deep dive into, Göran, later on with agricultural side and the tech scene, what's going on in a few months' time, actually. But I appreciate very much what you have been sharing here.
Pleasure.
Valuable time, fabulous insights. Thank you very much.
You're welcome.